Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the antiderivative of a rational function. Now, before we start, let's not forget that there are also some special cases for rational functions. We are just adding it here right after the discussion for the constant multiple rule, because this type of function here, we have the integral of your 2 over x to the power of 4 with respect to x can be expressed as a certain function with our exponent for our x is not equal to -1. Again, as mentioned, there are also some special cases for this, because if n is equal to -1 and for situations where the denominator of a certain function, in this case this one here, is a binomial expression, we are going to use another rule. But for this, we can rewrite this in this form, the integral of your 2, and as we apply the law of negative exponent, you can have your x to the power of -4 dx. Take note that our n as the exponent for our x is not equal to -1, hence we can use here the power rule. Yes, in the first place, it's identified as a rational function because it has a variable on the denominator, but once we structure it in this manner, the power rule is applicable. And of course, at the same time, the constant multiple rule as well. So we can do this here by factoring or taking out our constant multiple of 2 and having here the integral of x to the power of -4 with respect to x. Then we can apply here the power rule for this, which tells us that if we have the integral of x to the power of n with respect to x, as long as your n is not equal to -1, it's equal to x to the power of n plus 1 over n plus 1 plus your c. Okay, this is now equal to 2 times you have x to the power of -4 plus 1 over -4 plus 1 and plus c. As mentioned previously, this is supposedly to be multiplied with 2, and you will get here a second term which is 2c, but since c is an arbitrary constant, we can just go away with that and state the second term to be c later on. As we continue, this will become 2. You have your x to the power of -3 over -3 plus your c. Okay, because -4 plus 1 is -3. Then we simply need to take out the constants. You will get here -2/3 because you will have 2 over -3, this one here, and you will have your x to the power of -3 plus c. Now to finish this, since earlier our given function is a rational function, applying the law of negative exponent, we'll have this form, and since the final form here also has negative exponent, let's try to apply here the law of negative exponent as well. We'll have our final answer, which is -2 over 3x cubed plus c. We simply multiplied now the denominators to 3, and as you will have it here, you can actually have x to the power of -3 being 1 over x cubed. So we simply multiplied 1 to -2, so it's just -2 here, and again the denominator is a 3 times this, so 3x cubed. To verify whether this is correct, you can of course derive this or get its derivative, and if it would return to this given function or this function originally, then your answer is correct. Let us have you another example, and allow me to do that to solidify our understanding here. What if we have here the integral of -5 over y cubed? Okay, then we have here with respect to y. So what we can do here is, of course, again, use the law of negative exponent, -5 y to the power of -3 dy. Constant multiple rule, -5 is taken outside, y power of -3 dy. Then power rule tells us we have -5 y to the power of -3 plus 1 over -3 plus 1 plus c. Then you will have -5 y to the power of -2 over -2 plus c. Using this as a certain constant, you will get positive 5/2 y to the power of -2 plus c. And then again, applying the law of negative exponent, you will get here 5 over 2 y squared plus c. This is the result or the antiderivative of this given rational function. Again, you may want to derive this to verify whether the answer is correct or not. Okay? This is how we illustrate the antiderivative of a rational function where our denominator is of course a monomial expression, and when we apply the law of negative exponent, your n is equal to -1. If those two conditions will be failed, then we are going to use the specific rules for the antiderivative of certain rational function. Thank you very much for watching. So what are you waiting for? Subscribe now!